So on week number 9, you have a sketch design, Pergola sketch design that's going to be due. And this is what I'm looking for. It's all going to be on graph paper. You're not going to put it on just blank pieces of paper. Make sure it's on graph paper. And try to follow the line work. It should be fairly neat. And what you're going to do is show me how you're going to incorporate the different parts and pieces together to make your pergola a bit more decorative. So, I mean, this is the post. The post is something we all have on each of the pergolas, but how we actually connect the post and make it look in terms of a finish with the installation is really what's important. So I have a couple different details here. Now I've shown a 5-inch baseboard colonial. This is available at Home Depot Home Hardware. The size of the pine boards that I have for it, the chair rail, all of these elements you're going to note and find and then sketch out. So I've done a detail of the elevation of what this looks like, and then a profile, how I've actually put the pieces together. So there's my chair rail, there's my pine board, there's my casing, and then there's the deck itself, and then the support. These are the blocking members underneath the deck boards that will support the post itself, and that's what my section looks like. So that's what I commit to as far as my project. And then you're going to find your brace. And depending on the style of your brace, you will sketch it out. Just say that this is what I'm going to try to do to provide the brace. Now, why are braces important? I'm going to describe that a bit later on when we actually show you, or when I show you the CAD drawing that I've got prepared for you. And then obviously the end cut design, how I'm going to do this. And I'm using the squares as 2-inch modules. So 2, 4, 6, 8, even though it's 7 1/4 or 9 1/4. I'm just showing how I'm going to profile cut the end pieces for this particular part of the project. So that's my sketch design of the base, as well as any brace that I may have in this project. And I'm just going to turn this around so you can see some of the other notes I've made here. So I'm also going to expect you to do some sort of post and beam connections and how they'll look. And I'm drawing different views. So I've got a top view in here, I've got a sectional view in here, I've got another top view in here, and what I'm doing is I'm drawing out the posts. So I'm going to put that in a different color just so it stands out a bit more. So here I have the 4 posts. The blue's not showing up in here. No, I don't want any of that. There we go. So there are my 4 posts. And that's the only thing that you've shown on your deck design right now, where those 4 posts are. I don't know the dimensions necessarily. That's not important. But what I am showing in here, which is important, is how that beam is going to connect. So I've got a lintel that I'm going to be using here. It's 2-ply. Beams are 3 to 5-ply. And I don't want this. This is wrong, because this requires us to have the bolts carry all the load, all of it, from the structure above to the post, and that's not a very good design. So we never do this. What we try to do is this, and what that does is it allows us to carry the entire load from the wood to the wood, and then the bolt itself simply becomes a support mechanism, and it doesn't have to be a bolt, it could be a dowel. So that's the good design, and what I'm showing here is the top view. If you look above, we're actually notching into the post these 2 pieces of wood to support. This is the lintel in this case to support the ceiling weight. If I look from a side view, these are the same 2 pieces. So that piece, that piece are the same as this one and this one. And you can see how it goes right through the wood here. Well, the post is going to be notched out to support that weight. This is excellent design. The one beside it is horrible design. It's cheap, it's simple, and it relies on the strength of the bolts to carry the weight. And quite frankly, what happens over time is as the wood starts aging and drying, the bolts actually start leaning into that hole and they can adjust a bit. And that's not a very good design. That's why we try to stay away from that. And then we're going to look at, in your particular project, you're going to look at what are the distances you want to have in your particular application. So the distance between post here and the distance between post here are the key numbers. We need to find the 4 post centers. And the distance between the posts equal to the distance between the beams on this axis, which simply means all of our calculations as we start approaching it are that the center line of the post to the center line of the post is where we're going to be doing our calculations. This is where we calculate our beam, and then the center line of the post to the center line of the post. Sorry, let me draw that this way. This is where we're going to calculate. Sorry, I got that backwards. This is where we're going to calculate the span of the ceiling joist. This is where we're going to actually calculate the span of the beams. So those numbers are important, and you're going to be pulling that right off of your drawing. And then we'll work from there. Now, the other thing I wanted to mention to you, just like when we did post and beam construction, we're going to have overhangs. So there's our post, and we can actually overhang the lintel 2 feet maximum in this direction and the ceiling joist 2 feet maximum in this direction. We always measure it from the center line though. The center line, not the actual support area, but the center line, because these supports may change. So that's the way we always measure our dimensions when we're working with our profiles. And then how we're going to attach the ceiling to the actual beam or the lintel. Never notch the beam. I'm going to put that in red just as a little bit of a reminder, because I've seen this more often than not. This is a big no-no. The beam is what we calculate our spans on, and therefore it's going to be carrying most of the load. And because it does that, we always notch the joists in here and here. Oops. We always notch the joist in here and here to sit on top of the beam. It's usually no more than a 2-inch notch. And therefore, this actually provides security to the top of the beam. It laterally supports the beam in terms of its spacing. And then you can easily secure it or attach it to the post. Notice what I've shown is a countersunk post, or the beam. So it sits inside of that joint of the post, and then this sits on top of that. And I've indicated the notch. The effective depth, remember, is the part that's not notched. So if your ceiling joist calculations come out to a 2x6, in order to do this, you need to get a 2x8. Because a 2x8 cut back with the notch 2 inches, then makes it a 2x6. This last bit of unnotched material, or beyond the notch, is basically no longer part of the structure. The structure has a seam. As soon as you do that, it has a very critical seam, and that seam occurs right there. So that's the effective depth, and we never go beyond that. You can see I'm sort of trying to emphasize, never notch the beam, only the lintels, only notch the ceiling joists, and then make sure that the effective depth is not less than the joist depth itself.